So in this simulation, we're going to vary the two constants in nature. One is something called omega, which is basically a measure of how much space is curved. Omega bigger than 1 means there's a lot of mass in the universe to curve space into a ball. Omega equals to 1, it's not, it means it's just flat, the space is flat. And we're going to start with omega less than 1, means it's curved the opposite way. So in the very first question, assume the Hubble constant is 72. That's where we're going to put it over here. Set omega to a little less than 1, which I have, and see what the universe is like. Over here, you can see the stars. What's going to happen to the stars as you look at them. You can see the size of the universe over here, how big it will be. So let's start the Big Bang. The Big Bang happens right over here. And you can see that the Big Bang happens, the universe expands, and it never comes back. It doesn't collapse again. Okay, not with these values. Let's reset it and have another set of values. For example, let's make this a little more than 1, like 1.05. Let's reset it and start the universe again. Now you can see it does collapse, but way, the lifetime of the universe is going to be more than 20 billion years, probably double that or so. Let's reset that. Let's now let's do the second question. Now we're going to set h equals to 250 and omega to 1.69. Okay, and let's start the Big Bang. Well, now you can see the universe expands and collapses. The universe will live a total of approximately 12 billion years. Okay, and it'll collapse again and it'll expand again, collapse again and expand again. And so let's do question number 3. So there's another options to figure out which is the right answer. We're going to set all the options. First of all, set this omega at 1.75. And we're going to leave that at 1.75, and then let's change this. Let's put it at 72 to begin with, which is what we believe it is. Let's reset it and start the Big Bang and let's see what happens. You can see it's still an oscillating universe. Let's reset that. Now we'll set this at 50. What if Hubble constant was only 50? Start the Big Bang. So you can see how large the universe gets. It's the biggest it gets with those values. Let's set it at 100 now. And you can see that the change actually starts collapsing. And let's set it at 250. And you can see what happens there. The universe only lives for about 11 billion years. And finally at 200. Okay, so you can figure out the answer to this question.